Well, thank you, Tunneling Journal, for inviting me to talk today about digitalisation, the good, the bad, and the ugly. This is going to cover my 30-year journey as an IT-savvy engineering geologist trying to implement digital systems onto tunnelling projects around the globe. But I'd like to start by describing what I understand by digitalisation. Digitalisation focuses around data, but specifically about the management of risk using data, the productivity improvement you can get from data, but also ensuring that data stays alive from one project to the other. So this is knowledge engineering. And whilst there are buzzwords out there, the focus of this is in doing processes such as analytics, communicating data, making data available, enabling forecasting on the fly during jobs rather than once a job is finished. And then being able to make it so that you can automate all the processes that are there to enable things to be done in real time and without a lot of effort. And then obviously all of the data that needs to be covered is not just instrumentation in one hand or TBM data in another, but all the data across a project from safety to ground risk and hazards, obviously instrumentation, progress, production, and then control systems maintenance, then all the records and reports that normally get done. And no job is just a tunnel. It's also civil works or bridges or has tunnels or earthworks. So it really needs to be a system that is not focused on particularly one type of construction. And the other area that sort of limits what can be done with data is this sort of potential for things to be in silos. And then there's a need to remove proprietary barriers that may be there that stop the communication between software packages. On each project, the data cycle is starting really with the project planning and the investigation phase, where boreholes need to be accumulated and information about hazards and risk. And then that will be taken on during the design and prediction phase through outline design and tender design, detail design to produce inputs into a tender or into the production of the works. Then during production, it's not just about the progress of the works, but it's also about the records and the quality and the time and where everything's going that needs to be put in place. And at the whole time, everything needs to be monitored. So we've got feedback. And the feedback can include the instrumentation results, but also time and cost control, and also the opportunities through there to constantly do value engineering. And that doesn't stop there, because obviously there is an asset that is produced and that needs to be maintained and managed over a period of time. So that data really needs to feed into or feed from the data that we've accumulated during the period of construction. And then once we do this once, this cycle here leads into subsequent cycles, such that as an input, it aims to reduce the risk in each cycle. Then with the successive cycles, we will reduce the risk in projects or in a business. Now, when did this all start? Well, I can put it down to 2013 when McKinsey put out a publication saying infrastructure productivity, how to save 1 trillion per year. And obviously that was of great interest to clients around the world. But prior to that time, there was quite a lot of interest in digitalisation construction, as from this Google search. So what was actually going on before that 2013 article came out? Well, my own journey started in around about 1990 when I was one of the data engineers on the ground investigations for HS1. And there we used a format that had been developed by the Association of Geotechnical Specialists, which digitized data to provide a consistent lexicon for all sorts of contractors and everything else around the country. And we fed this into databases, which enabled us to do automated audit of the data, and then we could feed that into GIS, and then from the GIS and the database we could actually make scripts which would feed into CAD. And in this way we actually automated a lot of the design drawings and the cross sections that were produced for the project, and also some three-dimensional simulations of the ground. Now, on this project we actually used it to create a digital GI platform for the contractors to use at tender. And to my knowledge, in the last 30 years, this has never happened again. Now, I then went on to be a resident engineer on an active tunnel project, and it was great to see when I got there that some of the lessons from the Channel Tunnel had been implemented, in particular the codification of time on the job. The problem was that this was all in a mix of paper and word processing and spreadsheets and databases, and there was no real consistent way in which we've done. And the really ugly side of this was that at that time there was an impossibility claim leading to $500 million arbitration. And this is a collapsed tunnel on this project. Well, I managed to persuade the director of the project and the government to allow us to put in place a system. And this really is probably one of the first BIM systems on a job. Very simple, but it covered all of the time on the project, every 10 to 15 minutes. All the drilling, the grouting, the ground conditions that were encountered, and it had GISs in there that would look at the instrumentation results. And once it was put together, we could do things like this simulation of ground movements across a part of the works and going underneath a port. And you can see here the settlement of the ground as the tunnel goes past, and you can see weekly progress, you can see the groundwater, you can see the inflow within the tunnels in a colour. And this was of great value when it came to the arbitration. All these records were used then to come up with a successful conclusion. So what happened from 2000 to 2007? Well, this was what I call the GIS years, the rise in remote sensing, and a lot of GIS was there. And it came to the stage where a GIS was really a must-have on a lot of construction projects. A lot of people with GIS degrees were coming out, and it was really the place to go for monitoring records, particularly on jobs. Unfortunately, a lot of these things were used to just put things on maps and not to actually use any of the geospatial analytical tools that were there. Most of the stuff was done using Excel. And in 2005, the Joint Code of Practice came out from the British Tunnel Society and the International Insurers. And here they actually stipulated that there should be a use of systems on the project to actually manage risk. And these were put into the contractor specification. So they had to track the time, records, and open it up. So there was a good deal of transparency that was required. But what was the incentive for the contractor to do this, or to do this well? Did they consider it to be a noose by which they were going to hang themselves on a project? At the same time, CAD was developing, but it was still manual. And even though some 3D was being done, still the product was still 2D drawings. There was little automation except by enthusiasts. And interestingly, I was involved in a project where we were doing a lot of Autolisp development, and they decided they were going to invest in a platform that was really one of the first BIM and design platforms out there. They were looking to have the geotechnical design in there as well as the actual works themselves. And this is called Reflex. Reflex was actually bought by Autodesk, but then because it didn't fit, they then discontinued it. So there is a risk there in terms of investing heavily in these kind of systems, which I think put some people off at the time. Towards the end of the tens, there was a rise in machine data starting to become accessible. It was already being logged, but it wasn't actually made accessible to engineers. And this enabled engineers to start looking at process control, feedback systems, machine learning, and AI. And whilst this was good in TBMs, we're getting all that data. We weren't getting any data from road headers, drill jumbos, or piling rigs. In some cases, road headers, there weren't that many sensors on the machines. But on drill jumbos and piling rigs, really it just wasn't being captured and wasn't being sent through to the people who needed it. In fact, by 2015, we already had 15 machines on a single system, and we're looking at cutaway prediction, settlement management feedback, actually on the job while it was going. Now, later on, owners started to take control, and the LTA, they put out their own GDB system, the MTR had the UWDOS OS, the Crossrail had USIMS, and Singapore Power put in place the IDMS. And this IDMS was innovative in that it was covering all the I&M and all the construction works and the progress, TBM data, risk management. But what was innovative was that they put it out by going to partnering for information. So all 7 people on the job, from the client through 6 contractors, actually paid for the system to be put in place, and there was a single source of truth. And this worked incredibly well. And so much so that the Public Utilities Board, looking for a way to deliver their DTSS2 project, put this into their project as well. And this has become pretty much the only truly connected digital tunnel project worldwide at the moment. And here is the control room for the system, and there are all aspects of the tunnel are managed from this place, from this kind of information. And to give you an idea of the size of it, this is 100 kilometers of tunnels from 75 shafts, 20 TBMs on one system with 5-second latency getting to the data. All data is in there, including shift reports and site records and CCTVs and everything. All alarm records are managed through blogs within the platform, and there's over 900 users and over 75,000 pages of PDF produced every month. And there is not one of them is printed. And to see the way in which this has been developed, you can see that the numbers of logins here are evenly spread, or roughly evenly spread, amongst consultant, contractor, instrumentation contractor, and clients. So everybody is engaged on delivery of this project. So what about the acceleration in 2015? Well, really driven by McKinsey and PwC, the big guys, talking to governments and getting people going on the digitalisation plan. So, but is the data and software really the secret to construction? So, we can ask the accountants about this, and they have come up with some recommendations. And they've managed to persuade government that they should actually provide some incentives for people to do it. And this comes in the form of the Productivity Improvement Programme in Singapore, CITF in Hong Kong, and also in the UK, but Innovate UK. And in some places, actually, the government takes control and puts together teams who promote the best practice. So in the UK, we've got many of them: Project 13, Project Speed, CDBB, the Construction Innovation Hub, Digital Twin Hub, and lots more. With lots of work going on, this must mean that the costs are going up, surely. Now, in this sort of rush towards this digitalisation, the foundation of it was chosen to be BIM, and BIM had originated in architecture, which is still a headache for civil works, because there are still some things inherent there that just don't fit into tunnelling. Because of this, it was seemingly tied to CAD drawing tools, and I go back to what I said about GIS. This came back in the early 2000s. And wasn't this what we were going to do with that? Was it going to be a map-based interface to all this data? And what we did at this time was to try and standardize everything, standardize structure, standardize nomenclature, standardize communications. And in doing so, this put in quite a few sort of boundaries to what we were going to do. So the BIM really was a platform for the digital framework. They were looking at putting through a digital twin, and also they were going to put in place coordination bodies who were going to help to do it. But I point you at this figure here, the 840 million. This was the figure that was quoted as being the foundation for why this was going to be beneficial to the industry. Now, these statistics were put forward possibly by companies, individuals set to benefit. So I thought I'd have a look at where this 840 million document actually came from. And Digital Built Britain has a backup document called a Combined Evidence Volume. And within there was a reference to this. Use of BIM saved the public purse 840 million in 2013-14 and an estimated 1 billion in 14-15. But in this case, the reference, number 172, links to a rather obscure reference to power company works with regulated environmental tool. So I don't know where this original reference is, and I would like to see it. But what happened in 2018 is PwC were tasked with coming up with a methodology for quantifying what these potential benefits would be. And they have a table which identifies all the different measurement categories that they identified, with a sort of a score really for how much they do contribute. So I've been through this looking at, from my experience, which ones of these actually do, or actually how provide benefit and evidence benefit from my own background. And the first one, time savings. In terms of the definition of jobs, clearly the data that recorded on that HATS stage 1 was used in HATS stage 2. On the HS1, the planning for the boreholes and everything else, that was all fully automated and really helped to get these things out quickly with a small team. And things like the answering RFIs and incident responses and things like that, the use of blogs has cut that time down by about 80%. Handing over data at the end of the job is easy now digitally. There's no need to compile records, which is great. I don't see too many things in the material saving within tunneling, and the cost savings from better clash detection. Also, I don't see those quite so much. The cost savings from asset disposal I don't see, but I do see cost savings from the point of view of fewer changes. Cost savings in terms of the operations, all the data being easily to hand, you don't have to look for it. In terms of the cost saving litigation, clearly the fact that the client won the HATS arbitration, 6-6-6-1, and one of the arbitrator's comments was that the data that was used to support the government's case was significantly better than that of the contractors. So definitely getting all your ducks in a line has a significant benefit there. In terms of health and safety, we can do that on the system with the CCTV and the blogs and everything else, very, very useful in actively managing that. And in terms of the project reduce risk contingency, we actually reduce the project premium for insurance on the XRL Hong Kong by about 0.1%. So that's quite a big sum of money. Reducing the risk due to uncertainty in the operating expenditures. Obviously, the HATS 2 job, where we used the previous data as a input to planning the next job, was a key criteria. And I don't know why this score is so low, but anyway. And from an environmental point of view, obviously, creating all the records in a paperless way really does benefit that, and also less travel, because all the information is available online. They missed a few benefits, though. Obviously, a contractor, they want to use the data to win more jobs. The owner wants to use the data to benefit future planning. And obviously, improve lives. Engineers don't want to be just cutting and pasting all day, producing reports if they can be automated. I would definitely say observational engineering and to manage uncertainty, again, managing uncertainty through machine learning and AI, definite future possible benefits for digitalization. And then there are several intangible benefits which I'll gloss over. Now, in terms of how to deliver this, I remember Balfour Beatty's Cliff Moss, who was the HS1 chief engineer, dragging us up to the refectory to have a rant at us every now and again as consultants. And basically his beef really was that engineers will innovate for innovation's sake. We keep creating new stuff all the time, never making, taking the time to take the benefit of the stuff that we've already created. So we must stop reinventing. We must learn to use what we've created. We not stop reinventing the wheel and actually use that wheel to travel somewhere. And is the search for a single prescribed unifying specification structure the right way to go in all of this? Is there a better way? This is going to create task forces, working groups, authorities, produce lots of plans and specifications, and it will take a long time. Now, in software, we don't do this anymore, this rigid method. We use a method which is called Agile. Okay, Agile is a rapid prototyping and a successive prototype method which recognizes that when we start out on a journey, we don't know how exactly it's going to pan out. We're going to learn as we go, but we're going to make it flexible so that we can do that. And one way to do that is to agree a communication protocol that works like the AGS did to make sure that proprietary systems can cooperate, can communicate in terms of delivering what they want. So what would the enthusiasts from 1991 say? They'd probably say that where there's a will, there's a way. And really, in terms of the schemas needed to create the databases, the communication standards, whatever, we can do that. That's not difficult. But what about geometry? Can we actually communicate the geometry of a job? And I found that there are some severe barriers to that. First of all, It's hard to communicate geometry. It's not drawn in the same way. And there are no standards to the way in which things are drawn. You can draw a tube in many different ways, cylinders and cones and splines and extruded shapes. And this example on the right here is actually an IFC file, which is the interchange mechanism for most geometry stuff. And it's actually drawn triangles. It's 252 megabytes, which is huge. It can actually be drawn in just 10K if we get it right. And often drawn objects are wished in place, not built as they're built. And this creates great difficulty in connecting those things to records on site. So what have HS2 and other projects done to try to address this, or what are we doing with them? Well, first of all, we're trying to connect as many things as possible. So in terms of ground modelling, we're pulling in all the boreholes and enabling live sections to be drawn. And then through these live sections, being able to create three-dimensional models that can be linked and updated easily to the construction works. And these don't need to be just information about geology or geological formations. It can be about any parameter, such as this consistency index for the London tunnels. And we can also pull in this information from GIS. So here we're pulling in drone data, and it's not just to give a representation of the works, but also this is data you can use to calculate the applied load onto a foundation of an earthwork, for instance. And then from GIS itself, we can pull in the outlines of buildings and structures, tie instrument to those, and perform geospatial queries live in the system. From geotechnical design, what we want to do is get those predictions in, so we can pull predictions from programs like Plaxis and FLAC directly into the system. Combine that then with the progress, so we know what stage of the excavation something's at, and also then combine it with the instrumentation results. So in real time, we can see exactly what our expectation was and what the results are actually showing. And then from a tunnel point of view, we can create models that actually give us the expectation for what the settlement is to be compared with the actual design, so we can see as we are tunneling where we are relative to what the ultimate outcome is going to be. From BIM, we need to manage BIM from the point of view of design, which is going to change. So how do we manage that? So we built this into the system, whereby when the design changes, we can see that BIM data, and we can also marry it to production. So here you can see in light blue, you can see the piles that are being completed on the job, and they can be collected together to look at the program activity of piling a particular location and give the program its rate of piling on a particular project. And then we go through quality and records. We'll be looking to implement some of this within the systems, and then ultimately into the feedback mechanism. We've got over 60,000 instruments on the London tunnels alone. And we'll be linking the TBM data in and hoping to do active risk management and design feedback on that to be able to give real insights live into how the tunneling is going. And what we've done is to pull all this together into a real-time digital twin in GIS and 4D modes, created on the fly from the data. And what we do here is we use sort of gaming technology to be able to create just what you've chosen into a 3D digital twin that's nice and easy for you to navigate and actually get data directly from the interface as you require. And you can see here that the progress of the works is also being shown within the digital twin, in addition to the instrumentation results, and also the other boreholes and the topography. So to sum up, digitalisation is not a new thing. It's been around for 30 years. But the problem has been there's been an inertia to adoption, which I think seems to have been removed. It has been patchy and fragmented, not just in the past, but it's still patchy and fragmented now. And one of the reasons for that may be the contract methods for which we implement it on jobs. I would ask the question, is CAD the only way, or maybe other methods can give better accessibility, such as via GIS? I would say rather than implement rigid approaches, prescribed methods and everything else, make it agile, allow people to do their own take on digitalisation, but standardize the communication and translation of the information, so we can end up connecting lots of different softwares together. And ultimately, where there's a will, there's a way. And I think that we really need to incentivize people to do these things, not be overbearing in terms of the amount of records they have to produce, but really just promote use of digitalization to be a foundation for better communication, risk management, and project delivery. Thank you very much.